Hello everyone, and welcome back to the LefeWare Solutions channel, the place where we dive deep into the world of data and cloud technology. If you're new here, don't forget to hit that subscribe button and ring the notification bell so you never miss out on our latest content. Today, we're exploring the complex world of data warehouses and understanding their critical role in business intelligence and decision-making. Let's get started. So let's first address the question of what exactly is a data warehouse? Well, data warehouses are by no means a new concept, and they've been around for decades. They were developed as a response to the growing need for businesses to have a more consolidated view of their data, meaning businesses wanted a way to centralize data from different sources into one comprehensive database. This could be data from their customer relationship management system, ERP systems, marketing platforms, and even other relational databases. Many of our actual clients at LefeWare Solutions, they want their data consolidated into a single place. It allows them to ensure consistency. It eliminates data silos from different teams. And most importantly, allows them to retrieve and analyze data more efficiently. This centralized approach also means that data from various departments can be integrated, providing a more holistic view of the entire organization's operations. But it's not just about consolidation. There's like data warehouses, they're also optimized for performance, and they're structured in such a way that makes complex querying faster and more efficient, ensuring that these businesses can access insights quickly, which is so crucial in today's fast-paced market. While data warehouses are indeed a type of relational database, there are actually some slight differences from the conventional relational databases designed for day-to-day operations and which prioritize transactional data management. The conventional relational databases that you're likely used to if you're, say, a software developer, those are known as online transaction processing systems, or OLTP for short. And these databases, they're optimized for handling numerous users performing short and quick transactions concurrently, usually on up-to-date data. These OLTP databases, they also ensure an elevated level of data integrity through normalized tables and frequent updates, deletions, queries, insertions. Now, on the other hand, data warehouses, they're a specialized type of relational databases that are optimized for business intelligence and analytical activities. And they're often featuring a more denormalized data structure to optimize for complex queries and to reduce the need for multiple joins. And we'll be going into a little bit on the structure of those databases in a bit. But most of the clients that we work with, they have pre-existing OLTP databases, and oftentimes we'll help them set up their OLAP databases by using ETL processes, extract, transform, load. And this essentially, it enables the flow of operational data to analytical platforms where it can be transformed into valuable insights. Now, if you watched our last video on data lakes, you'll likely be thinking to yourself, this sounds awfully familiar to a data lake. Both data lakes and data warehouses are systems for storing large amounts of data in a centralized location, but they serve different purposes, have different architectures, and handle data differently. So first off is the type of data stored. As mentioned in our previous video, data lakes are primarily designed to store raw, unprocessed data. This can be structured data like databases, semi-structured data like JSON, or even unstructured data like images and videos. Now, data warehouses, they're designed to store structured, processed, and clean data. Next up is schemas. Data lake are considered schema on read, meaning that the schema is applied only when actually reading the data, allowing for greater flexibility in storing different data types and structures. Data warehouses have a schema on write architecture. This means data has a defined schema when it's loaded into the warehouse, requiring upfront data modeling and integration work, but it ultimately helps in much faster querying later on. Next is data processing. So since data lakes primarily store raw data, much of the processing likely requiring cleaning, transforming, aggregating, this actually happens during the read or the consumption time, making things a little bit slower. Now, data warehouses, the data is cleaned, transformed, and aggregated in ETL before it's actually loaded, which means that the data is ready to be queried. So things are very, very quick. Next up is scalability and storage. Data lakes are often built on top of distributed storage systems. Again, think of Hadoop's HDFS or cloud storage like Amazon S3. This ensures high scalability and makes it very cost effective for storing mass amounts of raw data. Now, data warehouses are built on performance database systems, which obviously is a bit more expensive per unit of data, but it really offers that fast, consistent performance that many organizations expect. It's important to note that data lakes and data warehouses, they're not competing technologies. And in fact, we often use them in tandem when setting up a client's data strategy. One point worth mentioning is the recent industry trend in the data engineering and analytics world towards the concept of a data lakehouse. The lakehouse is an architectural approach that combines elements of the data lakes and the data warehouses into a single unified architecture. These lakehouses aim to support both the vast data storage and processing needs of a data lake with the actual management and structured querying features of a data warehouse, along with ACID transactions. This topic, essentially, it warrants an entire video in itself and something that I plan to cover in a future video. At LefeWare Solutions, we focus primarily on cloud-based solutions. So I wanted to quickly list off some of the most popular cloud-based data warehouse options that we've helped our clients set up. To start us off, there's AWS, which has Amazon Redshift, which is a fully managed data warehouse service known for its fast query performance. We did an entire video on this. See the show notes for details. Next up is Azure has Azure Synapse Analytics, which was formerly SQL Data Warehouse. We also did an entire video on this, link in the show notes. Google Cloud Platform has BigQuery, which is a serverless, highly scalable, and cost-effective multi-cloud data warehouse. Video on this platform is actually still to come. Next up, there is Snowflake, which is a platform I'm not overly familiar with, but it is cloud native and provides data warehouse as a service. And then finally, Databricks, which actually doesn't offer a traditional data warehouse, but instead it provides a data lakehouse, which is what I actually just spoke on. In data warehouses, data is organized quite differently from how transactional databases are organized. Here, the data is structured into two main types of tables. We have fact tables and we have dimension tables. Fact tables record specific events or actions capturing the essence of exactly what happened. For example, a patient visited a clinic or a store made a sale. Dimension tables, on the other hand, well, they complement this by providing additional details about this event, such as the patient or customer info, the time, and the place in which this event occurred. This data structure forms what is known as a star schema. And this is due to the fact table and the surrounding dimension tables that they give the shape of what would appear to be a star. And this structure, it's specifically optimized for historical data analysis. The star schema is designed to simplify queries, allowing for efficient aggregation of data over time, making it ideal for tracking long-term trends, really. To really illustrate how data warehouses are used in the day-to-day operations for larger organizations, I actually wanted to share a project that we recently completed at LefeWare Solutions for one of our clients in the healthcare industry. Essentially, we helped them set up a data warehouse. So this client, they generated a large volume of daily electronic health records, or EHRs for short, around the patient visits for their network of clinics in the United States. They had terabytes of historical semi-structured EHR data, and this was stored in a series of Amazon S3 buckets. And they had a client application that allowed for the individual retrieval of documents from patients and doctors. So essentially, this client wanted us to enable some large-scale analysis on their EHR data. They wanted to be able to derive insights on population health trends, treatment outcomes, operational efficiencies, from their entire network of clinics, something that had not been possible up to this date. They also needed us to anonymize their EHR data before analysis could actually be completed in order to follow specific regulations like HIPAA, basically removing any personal identifying information from this data. So when wanting to analyze a large data set over time, the first step usually involves defining our data model. Since the client's primary focus was on knowing trends over time, specifically around patient visits, we wanted our model to really center around this fact. Therefore, we created this fact patient visit table. And as you can see here, it's mostly just a series of foreign keys that are linking to other dimension tables. So once we had the fact table in place around the patient visits, we then defined a series of dimension tables around this specific visit, including clinic information, so things like clinic name, the city, the address, patient information, over here, patient's name, gender, the patient's address, doctor information, and all these other dimensions associated with this initial fact. So obviously this is an oversimplification, but I think this kind of really drives home the point of this star schema. So once we had this data model in place, we would go in and we would actually create our star schema in AWS Redshift using SQL. Next, we needed a way to extract our EHR data from the actual S3 buckets. So first we have this HL7 data and this different EHR data that's flowing into our S3 buckets. So we used AWS Glue that essentially created a job that reads this semi-structured HL7 data files from Amazon S3. Next, we needed a way to anonymize and transform our data. Again, we utilize Glue's ETL capabilities to first anonymize the data, including removing any specific sensitive fields and replacing other fields with pseudonyms to ensure that we were in compliance with HIPAA standards. Finally, we transformed the semi-structured HL7 data into a structured format, and we used PySpark for this. Once the data was anonymized and transformed and into its proper structure, we loaded into the corresponding fact and dimension tables in the Amazon Redshift cluster. Finally, our AWS Redshift data warehouse had all the data that it needed, and it was ready to be connected to our business intelligence tools, where finally we could perform large-scale analysis on this EHR data and derive different insights and other important facts around this data. So if you're a growing organization that is looking to gain actionable insights from your data, you should be aware that implementing a data warehouse comes with its own set of unique challenges. This is where my team at LefeWare Solutions comes in. We will make the process so much easier. We would focus on navigating the technical complexities such as integrating various data sources, managing large data volumes, ensuring data consistency and accuracy, and implementing the effective data security measures on your data. With our expertise, we would streamline the setup process. We would help your organization to harness the full potential of a data warehouse without the usual hurdles. Click the link in the description below and book a call with us so we can see how we can help make this process so much easier. So in conclusion, data warehouses are more than just storage solutions. They are the engines that power business intelligence, helping organizations make informed decisions. If you found this exploration into data warehouses insightful, do hit that like button, share it, and subscribe for more tech insights. Have any questions or a topic you'd like us to delve into next, drop a comment below. This is Josh from LefeWare Solutions, signing off.